Hello children, welcome back to GradeBooster. Today we are going to discuss about the lesson acid, bases and salts. Acids, bases and salts. So children, in this lesson we are going to study about the properties of acids and properties of bases and the formation of salts, and what are the different type of salts and what are their industrial uses. Everything that we are going to study in this particular lesson. So this is a very important lesson in class 10 chemistry, right? So let us begin with acids. So what are acids? How can we say that these substances are acid? Here we have some examples of acid. Vinegar. Vinegar is an example of an acid. It contains a compound called as acetic acid. That is the common name of acetic acid is vinegar. Now, malic acid, that is present in apples. So apples contain malic acid. Milk contains lactic acid. Milk contains lactic acid. And ant sting or bee sting, it contains some acid called as formic acid. Grapes contain tartaric acid. And tomatoes contain oxalic acid. So these are all the general items that we use in our day-to-day life. So that means the different things that we are using in our day-to-day life, they contain acids. Some of them contain acids, some of them contain bases. So here are the examples of the different substances that contain acids. Here we can see that the grapes, tomatoes, vinegar, apple, you see all these things, when you taste them, how do you feel? What kind of taste you get? Sour taste. So this means that acids are the chemical compounds. Acids are the chemical compounds that are sour in taste. So this is one of the important property of acids. What is the important property of acids? Acids are sour in taste. You see these items, even the milk, if they are left at room temperature without refrigerating, they become sour. So the sour taste comes from the acid. So basically acids have the sour taste. That is one of the important property of acid. Acids turn blue litmus paper red. That is the second property of acids. Acids turn blue litmus to red. Don't worry about what is blue and red litmus. I will show you in the next slide. We'll learn about them. But remember this property, acids, they turn blue litmus to red. Okay. The third one. So first property, second property and third property. Acids often corrosive to metals. That means acids cause damage to metal. If some metal comes in contact with acid, the metal gets damaged. That is called as corrosive. Corrosive. Okay. So these are the three important properties of acids. There is one more property. If we dissolve some acid like HCl in water, if we dissolve HCl like some acid, HCl or H2SO4, if we dissolve an acid in water, it produces hydrogen ions. So the HCl, it splits into H plus and Cl minus ions. So H plus ions are produced when you dissolve some acid in water. That is another property of acids. So these are the properties of acids and these are the examples of acids. Now let us go to the next one, bases. Right, bases. So let us see what are the examples of bases. Sodium hydroxide, it is an example of base that is present in soaps. Sodium carbonate, that is present in detergents. Sodium bicarbonate, that is present in baking soda. And calcium hydroxide, present in cement. Ammonia. Ammonia is also a weak base. It present in fertilizers. Magnesium hydroxide is present in antacids. Eno is an antacid. So it is used when there is lot of acidity in our stomach. To neutralize the effect of acidity in our stomach, we take some antacids, they contain some base, right. So, these are the examples of bases. Apart from this, there are so many examples that are given in your textbook, you can see. So, general examples we are discussing here. Now, let us look at the properties of bases. What are the properties? In acids, we have seen how they taste. Acids, they give sour taste, whereas you see the bases, they are bitter in taste. What is the taste of bases? They are bitter in taste. The second property is that they are slippery. They are slippery and soapy to touch. Soapy and slippery to touch. And the third property, they turn red litmus to blue. If you dip red litmus paper in a base, it turns to blue color. Acids, they turn the blue litmus paper to red. Bases, red litmus paper to blue. And one more property is that if we dissolve some base like sodium hydroxide in water, it produces hydroxyl ions, OH minus. So, the NaOH it splits into Na plus OH minus. That is what happens. So, if an acid is dissolved in water, it produces H plus ions. If a base dissolved in water, it produces OH minus ions, hydroxyl ions. These are the properties of bases and these are the examples of bases. So, very common examples of bases that we know is that sodium carbonate and sodium bicarbonate, and these are the very common examples we know for bases. Now, let us look at how do we test the presence of acid and bases. How do we test them? Some solution is given to you in a test tube and you are asked to find out whether it is an acid or a base. What do? How do you find out whether it is an acid or a base? By doing some test. Okay, let us see what are those tests. So, here you can see something in this picture. This is litmus. So, litmus is a very popular, very common acid base indicator. Litmus is used to make litmus solution. At the same time, it is also used to make litmus paper. See, litmus papers. So, the litmus papers are available in two colors, red litmus paper, blue litmus paper. Now, let us see how they help to identify the acid or base. So, we can test the presence of acid or base using acid base indicators. Litmus is the important one. Litmus is the most popular acid base indicator and it is a natural acid base indicator. Children, remember this. Litmus is a natural. So, this litmus is obtained from a kind of lichens. Lichens are a kind of living things, right? In botany, in biology, we will study about lichens. So, lichens are the natural ones. From that lichens, this litmus is extracted and using the litmus, they make the litmus paper. Now, blue litmus paper, see here, this is the blue one. The blue litmus paper, if it is dipped in acid, it turns red. Blue litmus turns to red if it is dipped in an acid. In case of a base, if red litmus paper is dipped, it turns to blue. Red litmus turns blue for a base. So, if the red litmus changes to blue, then you can say the given liquid is base. If the blue litmus paper turns to red, you can say the given liquid is acid. Okay? So, blue litmus paper turns to red when dipped in acid. Red litmus paper turns to blue when dipped in a base. So, children, how do we identify the given solution is an acid or base? Simply using litmus paper. Litmus is a natural indicator. So, the litmus paper is of two types, two colors, red and blue. If the solution changes the red litmus to blue, it is a base. If the solution changes blue litmus to red, it is an acid. That's all. Now, let us go to the next. Other indicators. So, this thing we know, litmus paper. Litmus paper, red and blue. And what are these two? What are these two? Here we have two more. Here we have other acid base indicators. So they are methyl orange, the one which is in orange color, we can see methyl orange, and this is phenolphthalein. Methyl orange, phenolphthalein. These two are synthetic acid base indicators. These two are synthetic acid base indicators, chemical acid base indicators. They are also used to find out the given substance is acid or base. That is their use, right? So apart from litmus, there are some natural acid base indicators like red cabbage and turmeric and hibiscus. So these are the other natural acid base indicators. Even using these substances also we can identify acids and bases. So along with this, we can use substances like, we can use items like onions also to identify whether the given substance is acid or base. So these are all natural indicators. These two are synthetic, methyl orange and phenolphthalein. These are the litmus papers. So all these are acid base indicators. These are all acid base indicators. Now, what kind of results we get if we add methyl orange to an acid, if we add phenolphthalein to an acid? Let us see here, let us see the flow chart. So here is acid. So if blue litmus paper is dipped in acid, acid plus blue litmus paper, it gives red color. If a blue litmus is dipped in an acid, it changes to red. Okay. So if blue litmus changes to red, it is an acid. You can understand like this. If methyl orange is added to acid, if methyl orange is added to acid, it gives which color? Red color. Methyl orange gives red color with an acid. If phenolphthalein is added to acid, phenolphthalein is added to acid, it becomes colorless. We have taken some acid, some phenolphthalein is added, right? So it becomes colorless. That is an acid. We can get the indication that is an acid. Now let us see base. If we dip red litmus paper in a base, it changes to blue color. If we add methyl orange to a base, it changes to yellow color. Methyl orange to a base, yellow color. And phenolphthalein to a base, if we add phenolphthalein to a base, pink color. What comes? Pink color. So this thing you have to keep it in mind. This thing you have to memorize, remember for your exams or whatsoever it is. So by that you can write any sort of question based on these acid base indicators. Right, children? So let us go to the next one. So we studied about acid base indicators. Right, children? And we are given all the acid base indicators for us. We are given litmus papers, we are given methyl orange, and we are given phenolphthalein. All the items are given to us. And we are given some kind of substances also on the other side. Let us test all these substances. So what kind of results we get? So by that we can say whether this substance, what type it is, whether it is an acid or a base. First one is HCl. So if HCl is tested with litmus paper, HCl changes blue litmus to red. If HCl is treated with methyl orange, red color is produced. If HCl is tested with phenolphthalein, no color change. Okay, or you can write colorless. Colorless. Next, H2SO4. So what are these things indicate? Blue to red and methyl orange red color, phenolphthalein colorless. This is an acid. What is this type? This is an acid. So H2SO4. H2SO4 also the same. Blue litmus changes to red. Methyl orange, it gives red color, and phenolphthalein also same colorless. So this is also H2SO4 is also an acid. HNO3 is also an acid because it turns the blue litmus to red, and methyl orange it gives red color, and phenolphthalein colorless. And CH3COOH, this is also the same acid. Red color with methyl orange, colorless with phenolphthalein. Litmus test, blue changes to red. Next, sodium hydroxide. It turns the red litmus blue. Sodium hydroxide turns the red litmus blue. And when it reacted with a methyl orange, it gives yellow. And when it reacts with phenolphthalein, it gives pink color. Pink color, sodium hydroxide. So, what type of substance this is? What type of compound it is? Base. Sodium hydroxide is a base. And the next one is calcium hydroxide. It turns the red litmus blue, and with methyl orange it gives yellow color, and phenolphthalein it gives pink color. So this is also a base. We can say that this is a base. And potassium hydroxide also a base. It turns the red litmus to blue, and it gives yellow color with methyl orange and pink color with phenolphthalein. Magnesium hydroxide, base, red to blue, yellow, pink with phenolphthalein. And ammonium hydroxide, it's a base, and in litmus test it changes red litmus to blue, and methyl orange it gives yellow color, and with phenolphthalein it gives pink color. So right children, so here we are given a list of items: HCl, H2SO4, HNO3, CH3COOH, all these are acids. Sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide and ammonium hydroxide, these are all bases, right? So now it's very clear for us that what kind of color is produced with methyl orange and with phenolphthalein with acids and bases. So by that easily we can identify, and we'll be able to write any sort of question that comes related to these acid base indicators and about their colors. Right children, next we are going to see reaction of acids with bases. When acids are reacted with bases, what happens? When an acid reacts with a base, neutralization takes place. So that reaction is called as neutralization. Here we have some experiment to understand the neutralization reaction, how an acid and base reacts. So for this experiment we have taken a test tube, and in the test tube we have taken dilute sodium hydroxide, means one base we have taken, and to this base we are adding few drops of phenolphthalein. You know phenolphthalein is an acid base indicator, few drops, and you know that when phenolphthalein is added to a base it produces pink color. So it produced a pink color. Here you see the change. So phenolphthalein is added to sodium hydroxide, it changed to pink color. Now to this test tube we added few drops of HCl. Now what happens? When few drops of HCl is added, the pink color disappears. Again we added few drops of sodium hydroxide. The pink color reappears. When HCl is added, pink color disappeared. When sodium hydroxide is added, pink color reappeared. So why it is happening like that? Okay. So this is the experiment. Step 1, 2 ml of sodium hydroxide, 2 drops of phenolphthalein, it gives the pink color. And step 2, we add few drops of HCl, the pink color disappears. And again few drops of sodium hydroxide, the pink color reappears. So why it is happening like that? See children, sodium hydroxide reacted with the phenolphthalein and it gave the pink color. Now this is in basic in nature. When we add HCl, that means when we add an acid to a base, this acid, it will reduce the basicity of that solution. The alkalinity of the solution is reduced or completely removed. When we add an acid to a base or a base to an acid, their acidity or basicity is reduced or completely removed. Okay. So here it is a base, so it gave pink color. By adding HCl, it's not a base. Its basicity is reduced or completely removed. Okay. So acid reacts with a base, and this reaction is called as neutralization reaction. So in this experiment, we have seen that adding an acid to a base can reduce or completely remove the basic nature of the substance. We added some acid to a base, so it removes or reduces the basic nature. In the same way, by adding a base to an acid, when we add a base to an acid, it can reduce or completely remove the acidic nature of that substance. So these type of reactions are called neutralization reactions. Base plus acid gives rise to salt plus water, right? So when a base is added to a acid, what is produced? Salt and water are produced, right children? So this is about the neutralization reactions. Next we see the reaction of metal oxide with acids. What happens if we add acid to a metal oxide? So what metal oxide we are taking here? Copper oxide. We have taken some copper oxide in a beaker, some copper oxide, and we are adding some acid to that. Which acid we are adding? We are going to add HCl. So copper oxide plus HCl. So when they both react, they give out a color called as bluish green color. Which color they give? Bluish green color. What product is formed? When a metal oxide reacts with acid, copper oxide reacts with HCl. So it gives a product called as copper chloride, CuCl2. It is a salt plus water. So when a metal oxide reacts with an acid, it gives out a salt and water. So we have taken some copper oxide in a beaker and added some dilute HCl slowly by stirring. How to add that? Slowly by stirring. Slowly by stirring we have to add. Now the color of the solution changes to blue-green color. Blue-green color. And what is the salt formed? Copper chloride and water. Right? Next, non-metal oxides with a base. So what happens when a non-metal oxide reacts with a base? So here what non-metallic oxide we are taking? Carbon dioxide we are taking, non-metallic oxide. And what base we are taking? Calcium hydroxide. Calcium hydroxide and the non-metallic oxide, that is carbon dioxide. Now let us see what happens. So when they both react, it forms a white precipitate. A white precipitate, that is nothing but calcium carbonate. Calcium carbonate is a salt. So here in the test tube, so we are passing carbon dioxide gas through the test tube into calcium hydroxide. Here in the test tube, we have calcium hydroxide. So calcium hydroxide, it reacts with carbon dioxide and forms calcium carbonate, a salt. So a non-metal oxide reacts with a base, it forms a salt and water. Next, now let us see the common things in both acids and bases. So far we have seen what are the differences. Now let us see what are the common things in both acids and bases. So here is an experimental setup. So what is this experiment about? Electrical conductivity of acids and bases. So do acids and bases conduct electricity or not? We are going to test. So for this we have a setup here. There is a power source and here is a bulb and here is a circuit connecting two wires from the power source, positive and negative terminals, and they are connected to two metal rods or nails and they are immersed in some solution in a beaker. This setup we have taken. So here in the beaker, we are going to change the liquid and see whether which liquid is conducting, which material or which substance is conducting electricity and which one is not conducting. So first, in the step 1, take some dilute HCl in the beaker. So here we have taken dilute HCl and we switched on the power source. The power is passing through the circuit. It is passing through the circuit, and it is, what happens here? The bulb glows. So when we have taken here HCl, then the bulb glows. The bulb glows for HCl. So the current flows through the solution and the bulb glows. And in second step, now we are taking out this HCl, remove the HCl, and what we are taking? Glucose solution. Glucose. Second thing we are taking is glucose. So when we keep glucose and we switch on the power source, the bulb does not glow. So the glucose is not conducting the electricity, but whereas the HCl acid, it conducts electricity. So the third one, we are going to take some alcohol. Alcohol. What happens with alcohol? Even with alcohol, no, the bulb does not glow with alcohol. So we removed that alcohol from the beaker, and again we have taken sodium hydroxide. What happens now? The bulb glows with acid. Does it glow with a base? Yes, the bulb glow with sodium hydroxide. So acids and bases, they conduct the electricity. What we confirm here? Both acids and bases, they conduct the electricity, right? So first we have taken HCl, the bulb glows. Next we took glucose, the bulb doesn't glow. Next we took alcohol, the bulb doesn't glow. And finally we have taken sodium hydroxide, yes, the bulb glows, right? So with this experiment, we can make a statement that acids and bases, they have the electrical conductivity. They conduct electricity. Next, acids and bases, when they are dissolved in water, they produce ions. We studied this in the property of acids and bases. When we studied the property of acids, when some acid is dissolved in water, it produces hydrogen ions, H plus ions. When a base is dissolved in water, it produces OH minus ions, hydroxyl ions. Yes. See here, when some acid is dissolved in water, it produces H plus and Cl minus ions, H plus, Cl minus, positive and negative ions, right? So acids and bases, when dissolved in water, they produce cations and anions. Cations are the positive charged ions and anions are the negative charged ions. So Cl is the anion and OH is the anion, negative charged. Positive charged ones, sodium and hydrogen. So the positive charged ions are called as cations and negative charged ions are called as anions. So the common thing among acids and bases is that they both produce ions in water and they both conduct electricity. These two things we have learned from these two experiments. They both produce ions in water and they both conduct electricity. So they are able to conduct the electricity because of this ion formation. Both are interlinked. Since they are able to form the ions, they are able to conduct the electricity. So next topic is dilution. So dilution of acids and bases. So what is dilution? Adding water to acid or base, it is dilution. So here let us see how to do the dilution. What is the correct way of doing dilution? That means how to dilute an acid or a base. If we mix an acid or a base with water, it results in the decrease in the concentration of ions per unit volume. See here we have two flasks. So in these flasks there is some water, here there is some acid or a base. Some substance is dissolved, here ions are formed. So that the same substance is diluted with by adding some water. So when water is added, the volume increases, but the number of ions remains same. The same ions, they take more space. Okay. So here they took less space. When you are adding some water, the quantity of the total solution increases, but the number of ions remains same. So here the concentration of the ions is more. Here the concentration of ions per unit volume are less. Per unit volume they are less. Say for example 1 unit volume you take only 3 ions. The same volume you take 4 to 5 ions here. So in the same volume here more ions, less ions. So that is what called as dilution. So the substance it get diluted by adding water. Right. So now this process is called as dilution. There is a decrease in the concentration of ions per unit volume. Dilution is highly exothermic reaction, exothermic in nature. Dilution is an exothermic reaction. You know what is exothermic? The chemical reaction in which energy or heat is released, liberated out. It is exothermic. Heat comes out. So when the dilution takes place, heat is produced. Here you can see the red color of the test tube which indicates that heat is produced. So when the sulfuric acid is added to water, it's an exothermic reaction. Heat is released. Now, how to dilute an acid? Always add acid to water. Always add, if you want to dilute some acid, add acid to water. Not the water to acid, which is very, very dangerous. You cannot directly add water to acid. It's quite dangerous method of dilution. So always you should add acid to the water slowly by stirring. So always add acid to water slowly by stirring. Never add water to acid. Never add water to acid. Remember this, children. If water is added to acids, it splashes out. So it may fall on our body and may cause serious burns. That is due to local heating. So the local heating takes place if the water is added to acid. So always it is advisable or suggested to add acid to water for dilution. Next, the strength of acids and bases. So all acids and bases are not having same strength. Some are strong acids, some are weak acids. Some are strong bases, some are weak bases. On basing what we decide the strength of the acid. How we can say that this acid is strongest, this acid is weak. How we can say that this base is strong and this is weak? That is with the help of a pH scale. Let's see, this is the pH scale. So the pH scale has got the color indication. And here you can observe numbers on the pH scale. They start from 0 and ends with 14. So the substances which have the pH 0 to 7, they are all acidic substances or acids. If a substance pH is below 7, 6, 5, 3, 4, 3, 2, 1, 0, so that is they are acidic. If the substance pH is this between this range 4, 5, 6, 4 to 7, it is weak acids. That particular substance is a weak acid. If its pH falls between from 4 to 7. If the pH of the substance is very low, 3, 2, 1, between 1 or 0, they are very acidic. That means strong acids. They are strong acids. The substances with this pH 4 to 7, they are weak acids. So if it is 7, 7 is neutral. 7 is neutral. So 4, 5, 6, up to this range, they are weak acids. But when it reaches 7, 7 is neutral. It is neither acidic nor basic. Here, if the substance pH is 8, it is basic. But it is a weak base. 8, 9, 10, at this range, weak base. So these are the strong bases. After crossing 11, 12, 13, 14, strong bases. So any substance with 14 pH is a very, very strong base. Right, children? So we see different substances in our day-to-day life. Already we discussed the examples of different substances. So if you see their pH, you can understand their strength. Which one is a strong acid, which one is a strong base, which one is a weak acid, and which one is the weak base. Next, let us see the importance of pH in plant and animal life. So pH plays a very important role even in our body. pH plays an important role, even in the plant life and animal life. See the aquatic animals like fishes, their life is dependent on the pH of the water. Sometimes the pH of the water is altered due to certain conditions like acid rains which make the water acidic. So water in fish, they cannot live in that, too much of acidic water, and the fish they die during acid rains because of acid rains. So plants and animals are very much affected by the pH. Even the plants are affected by the pH of the soil. So farmers, they time to time take the samples of the pH soil and test the pH of the soil. Basing on that, they will apply the fertilizers or other chemicals to maintain the balance in the balance of the pH. So a pH of soil, water and all these are very important for the plant and animal life. Even you see that fish farms, people set up farms, fish farms. So hatcheries for fish and prawns, prawn hatcheries, the pH of the water is very important. If suddenly there is a change in the pH of the water, all the prawns will die. The farmers get a great loss. So pH plays an important role in the aquatic life and even in the farming, that is for the plants also. Let us see the role of pH in our stomach. Let us see in our body. In our body, pH plays an important role, especially in the stomach. So in our stomach, some acid is produced. You all know, that is HCl is produced. So this acid is very important to activate some enzymes, protein digesting enzymes, and to kill the microorganisms that are ingested along with the food. So it has different roles. That acid has different roles. And this acid is produced in our stomach, that is to digestion, that is to digest the proteins, that is to kill the microorganisms. But sometimes if this acid is produced in large quantity, it leads to a burning problem, condition in our stomach called as acidity. We feel that burning due to excess production of acid. So this acidity, to resolve this acidity, to treat this acidity, we will be taking antacids, which are a kind of base which will neutralize this acid. So when there is a lot of acid production in our stomach, we will take some base as an antacid which works against this. That means it reacts with the acid and it neutralizes the acid. Antacids like magnesium hydroxide are used to reduce the acidity. So the antacids, they contain substances like bases like magnesium hydroxide which react with the acid and neutralize the effect of the acid. Next, role of pH in our tooth decay. So the tooth decay, it happens, because of the acid production by bacteria. The bacteria present in our mouth, they feed on the sugars present on our teeth. When we eat some chocolate or something, some sugars are sticking to our teeth. They are left on the teeth. So on these remains, bacteria, they grow. They eat the sugars and they produce acids. These acids, they cause damage to our enamel. So our enamel is made up of a substance called calcium hydroxyapatite. Calcium hydroxyapatite is a material by which this enamel is made. It is the strongest material of our body enamel. But it is dissolved by the acids produced in the mouth by the bacteria. So the mouth pH, it goes below 5.5. So at this pH, the teeth are damaged. Next. So living things, they use acid and bases for their self-defense. Living things, they use acid and bases for their self-defense. Plants and animals, right? So you know that bees and ants, when they bite, when you get an ant bite, you get a lot of pain and irritation. So why? It is because of the ant injecting some acid into your skin, that is formic acid. Even the bee sting, to neutralize the effect of this, we apply some baking soda, which is a base, reacts with that acid and neutralizes its effect. So here, bee sting has an acid which causes pain and irritation. As a remedy, we use baking soda. And nettle leaf sting causes this kind of rash. So it is because of its acidic effect and neutralized by dock plant. This is the dock plant. So what does this dock plant do? It neutralizes the effect of the acidic reaction caused by the nettle leaf. So like this, even plants and animals, they have their defense mechanism in which they release or produce acids to protect themselves. So to get relief from the pain or irritation caused by these things, we use bases to neutralize their effect. Now let us see properties of salts. Properties of salts. So we studied about acids and bases. Now the salts. Salts are of different types. There are some salts which are neutral in nature. Example, potassium sulfate. There are some salts which are acidic. Acidic salts, example, ammonium chloride. And some salts are basic. Example, sodium carbonate. So salts are of different types. Neutral, acidic and basic. Now let us see how a neutral salt is produced. The neutral salt pH is 7, equal to 7. A neutral salt is produced when a reaction between a strong acid and a strong base takes place. A neutral salt is produced. When a strong acid and strong base reacts, neutral salt. When a strong acid and weak base, strong acid, weak base, then acidic salt, its pH is less than 7, acidic salt. Now, weak acid, strong base, then basic salt is produced. Its pH is greater than 7, it's basic salt. Right, children? So this is the way how neutral, acidic and basic salts are produced on basis of this combination. Which type of acid and which type of base are reacting depends upon the property of the salt, depends whether it is neutral, acidic or basic. Next, common salt. So we are talking about common salt. This is a very, very important one because common salt is the precursor. That means that is the raw material to make so many industrial chemicals. Many industrial chemicals, salts and other substances are made from the common salt. So the common salt, chemical name is sodium chloride and formula is NaCl, sodium chloride. Usually we get the sodium chloride, this salt from the seawater. Seawater contains so many salts dissolved in it. They will purify that, remove all the unnecessary salts and they take the sodium chloride out of it. So that is the white salt that we use even at our homes. And we see some other salt, rock salt, which is pink in color in the big crystal form. So it is mined like coal from the earth. So that rock salt is formed by that dried up oceans. So the dried up oceans, ancient oceans, they get dried up and all the salts are solidified into crystals, large crystals with so many impurities. So that is that rock salt, right? So whatever it is, the salt, the NaCl is the main component for making substances, various chemicals like sodium carbonate, sodium hydroxide and bleaching powder. So all these things are made from the sodium chloride. Let us see how these substances are manufactured from the sodium chloride. Right, children? Now here let us see what are the different kind of substances, chemicals that can be produced from sodium chloride. Sodium chloride is the raw material. So by using sodium chloride we can make caustic soda, that is sodium hydroxide, we can make baking soda and we can make washing soda and we can make bleaching powder. So all these substances can be manufactured from sodium chloride, that is salt. So now let us see the manufacture of sodium hydroxide, how sodium hydroxide caustic soda is made. Here is a setup, here is a tank, you can see a tank. The tank is having two electrodes, one is cathode and one is anode, and the tank is made into two chambers by a membrane at the center. You can see the membrane here. And to this chambers there are some inlets and outlets. So if you see the chamber, this side, that is towards the side of the anode, brine is entered into the tank. You know, brine means salt water is entered. Once the salt water enters, what is salt? NaCl. Here it divides, it splits into Na and Cl. Na plus and Cl minus, ions are formed, ions. So the sodium ions are migrating to the other side through the membrane. They are moving towards the cathode, right? Here chlorine ions are formed here. So NaCl is separated, it splits into sodium and chloride ions. So the chloride ions are collected here. So at this side we see the formation of chlorine gas, right? So the chlorine gas is released here. We can see the release of chlorine gas. Now what happens to this sodium which migrated to the other side? So this sodium, here it reacts with the hydroxyl ions. It reacts with the hydroxyl ions. From where these hydroxyl ions have come here? So the other side of the chamber, the water enters in. The water splits into hydrogen and hydroxyl ions, H plus and OH minus ions. So the hydrogen is liberated out in the form of gas, hydrogen gas, whereas the hydroxyl, OH minus ions are attached to this sodium and it forms sodium hydroxide NaOH. So here through this outlet the caustic soda goes out. So here the caustic soda is produced, here hydrogen is produced, here chlorine is produced. So three products are produced in this setup. So electricity is supplied here to the electrodes. So here the salt water splits into sodium and chloride ions, water splits into hydrogen and hydroxyl ions. So here the sodium react with the hydroxyl ions and form sodium hydroxide. So here this is an aqueous solution of sodium chloride. It produces three products. What are the three products? One is sodium hydroxide, second one is the chlorine gas, and third one is the hydrogen gas. Three products, and this process is called as chlor-alkali process. It's called as chlor-alkali process. So what are the different products? Chlorine gas, hydrogen gas, sodium hydroxide. This chlorine gas is used in water treatment, swimming pools, manufacture of PVC, disinfectants, chlorofluorocarbon and pesticides. In all these the chlorine gas is used. Hydrogen gas is used as a fuel and it is used in making of margarine, it is used in the making of fertilizers. Sodium hydroxide, it is used to degrease the metals, making soaps and detergents, making paper and artificial fibers. Sodium hydroxide is used. So all the three products that come in this setup are useful. These are the uses of these three: chlorine gas, hydrogen gas and sodium hydroxide. Next, manufacture of baking soda, that is NaHCO3. How the baking soda is made? So when the common salt, that is NaCl, is treated with water, carbon dioxide and ammonia. See, NaCl, water, carbon dioxide, ammonia, NH3. So when these things are reacted, NH4Cl, what is this? Ammonium chloride. Ammonium chloride is formed plus sodium bicarbonate, that is the baking soda is formed. This is the product. So the sodium bicarbonate is made in this way. So what are the uses of this baking soda NaHCO3? It is used in cooking and baking. It makes the cakes and bread spongy because the baking soda is added. So when it is heated, it releases carbon dioxide gas. This carbon dioxide gas, it forms the bubbles in the dough. So it makes it spongy and it is used as a cleaning agent, deodorizer. It removes the bad smell. So the baking soda is used to clean the carpets, it is used to clean the mattresses. So all the bad odor will be removed. Okay. So deodorizer neutralizes the bad odors in refrigerators, shoes and carpets. And sometimes it is used in toothpaste for whitening of teeth, and it is used as an antacid. So people suffering from acidity, they use some baking soda mixed in water as an antacid to neutralize the effect of the acid, so that it is used to relieve the heartburn, acid indigestion by neutralizing the stomach acid. And next, fire extinguisher. Sometimes the baking soda, it's used as a fire extinguisher as it can produce the carbon dioxide gas when heated. And washing clothes, sometimes the baking soda is used in, of course, washing soda is used for washing. The baking soda is also used for certain purposes. For example, if you want to clean vegetables, remove some kind of pesticides and other scum from the vegetables, we add baking soda and clean them, right? So baking soda is used for cleaning also. Next, do you know why baking soda is added to food items? Baking soda is added to food items. Why? Because already we discussed it. When food items like cakes, bread, they are added with baking soda. So this baking soda, on by heating, it produces carbon dioxide gas. So this carbon dioxide gas, it forms bubbles, and these bubbles, they get trapped in the food item. For example, this is the piece of a cake. So these gas bubbles, they get trapped here and they make the cake sponge and fluffy. The sponginess of the cake, the pockets of air present inside the cake, they come from the carbon dioxide released by the baking soda. So when the baking soda is heated, it produces carbon dioxide. That is the reason to make the food fluffy and spongy, they add baking soda to the food items. Next, now manufacture and uses of washing soda. So manufacture and uses of washing soda Na2CO3. So that is washing soda. Okay. So the formula is given wrong there. So recrystallization of sodium carbonate, it gives washing soda. So sodium carbonate recrystallization, that is, it is reacted with water. Okay, sodium carbonate is reacted with water to form the, sorry, this is not baking soda, washing soda. So the washing soda is formed. This is the formula for washing soda. So to make the washing soda, sodium carbonate is treated with water. So that is the recrystallization of sodium carbonate gives washing soda. Okay. Next, manufacture and uses of washing soda. What are its uses? Uses of washing soda, it is used in glass, soap and paper industries. What is that? Glass, soap and paper industries. Washing soda is used. It is used in the manufacture of borax. And it is also used as a cleaning agent. Washing soda is used as a cleaning agent. And it is used to remove the permanent removal of water hardness. So hard water, to remove the hardness of water, this washing soda is used. These are the uses of washing soda. And next, manufacturing the uses of bleaching powder. Manufacturing uses of bleaching powder. So calcium hydroxide is treated with the chlorine gas produced during chloralkali process to prepare bleaching powder. So in the chloralkali process, this process we have already seen before, manufacture of caustic soda. So caustic soda is manufactured in this process, chloralkali process. In this process, chlorine is also produced, chlorine gas. So this chlorine gas, whatever it is produced during chloralkali process, that chlorine gas is treated with calcium hydroxide, and so this reaction like calcium hydroxide plus chlorine gives rise to bleaching powder plus water. So this is how bleaching powder is made. So bleaching powder, to make bleaching powder, the main ingredient, the constituent is that chlorine. It reacted with calcium hydroxide. Calcium hydroxide plus chlorine reacts and forms the bleaching powder and water. So what are the uses of this bleaching powder? It is used in whitening of cloth. So while manufacturing so many items, to give them bright color, white shine, chlorine is used. Chlorine is used to whiten the paper. See, in your notebooks you are using some paper, white color paper. So the paper brightness or whiteness of the paper comes with the chlorine treatment. If the paper is not treated with chlorine, it will be in some pale, yellow color, half white color, not fluorescent white, bright white. So to get the bright white to your paper, it is treated with chlorine. In the same way, white cloth and jute, linen fibers in their manufacture, chlorine is used. This bleaching powder is used, and it is used in industries as oxidizing agent. It is used as a disinfectant. See, they sprinkle this bleaching powder near the garbage bins, toilets. So that is to prevent the infection of disease causing organisms. To disinfect the areas, they use the bleaching powder. It is sprinkled in public toilets, garbage bins. So that is the white color powder they sprinkle on the sides of the road, nothing but the bleaching powder. The bleaching powder is also used to clean the toilets. So it's a very good disinfectant. So the bleaching powder is made from chlorine, right? So bleaching powder is used in the whitening of cloth, whitening of paper and jute, linen fibers, and all these things. So these are the uses of bleaching powder. Next, manufacture and uses of plaster of Paris. Plaster of Paris, in simple terms, it is called as POP. So the plaster of Paris is used to make ceilings. In our houses, false ceiling will be done, decorative ceilings. To make these ceilings, plaster of Paris is used. So why it is called as plaster of Paris? Why it got the name plaster of Paris? Because in 18th century, extensive mining of gypsum was done. It was started in Paris. So for the large scale production of plaster was produced in large scale for buildings and all. So the mining of gypsum was done in Paris. So then it's being called as plaster of Paris. So POP. Now, so this plaster of Paris, where is it used? It is used by doctors when there is a breakage of bone. So the plaster is used to give a support to the hand. For the broken legs and hands, doctors use plaster of Paris to make that bandage. So by that it becomes hard and it gives support to the broken bone to get attached. It gives support to the broken bones. It also used in making toys and models. Some plaster of Paris models are made for ceilings, ceiling borders, this kind of decorative work they do with plaster of Paris. Okay. So this is all about acids, bases and salts, children. So in this lesson we have seen the properties of acids, properties of bases, and the properties of salts, the reactions of acids with metals and non-metals. So the reactions of base, and we have seen different type of salts, the common salt, and what are the different kind of products that are produced from common salt. What are their, what is the procedure of manufacture? So how these substances are manufactured and what are their domestic uses and industrial uses, everything we have covered in this chapter, acids, bases and salts. So if you like this video, you please give a like and please share your thoughts in the comment section. Please share this video to your friends and please subscribe GradeBooster channel for more informative and detailed video lectures and for animated videos. Okay, we'll meet in the next video. Till then, take care. Bye bye. Thanks for watching. Please like the video. Please share this video with your friends. Please subscribe to GradeBooster channel. Press the bell icon to get all the latest updates. Check the description to find links of other useful videos. Check the end screens for our new videos.